Hello and welcome to The Sleepy Physicist. I'm so glad you found your way here tonight. Whether you're settling in for the evening, curling up with a warm drink, or simply seeking a moment of quiet wonder in your day. This is our gentle corner of the universe where physics meets philosophy, where the impossible becomes inevitable, and where the deepest mysteries of existence unfold at a pace that lets your mind truly absorb their beauty. Tonight, we're embarking on a journey to a place that exists all around you, within you, and yet operates by rules so strange they would make Alice's Wonderland seem perfectly ordinary. We're venturing into the quantum realm, a dimension where particles can be in two places at once, where observation changes reality itself, and where the very act of measurement creates the world we see. But here's what will truly astound you. Recent discoveries have revealed that this isn't just some abstract playground for theoretical physicists. The quantum realm is actively shaping your reality right now, in ways that would have seemed like pure magic just decades ago. Before we begin this exploration, I'd love to know where in the world you're listening from tonight, and what time it is in your corner of existence. Whether it's a quiet midnight in Melbourne or a peaceful afternoon in Minnesota, you're very welcome here. And if you find these gentle journeys through the cosmos soothing, consider giving this video a like and subscribing to The Sleepy Physicist. It helps others discover this tranquil space where science becomes poetry. Now, I should mention that while tonight's exploration is designed to be both fascinating and relaxing, quantum mechanics has a peculiar way of being so intriguing that it might just keep you awake a bit longer than planned. If that happens, well, at least you'll drift off with your mind full of the most beautiful mysteries the universe has to offer. So take a deep breath, let your shoulders relax, and prepare to discover what's actually inside the quantum realm. Because what we're about to explore isn't just theory anymore, it's the hidden foundation of reality itself. Picture, if you will, holding a coin in your hand. In our everyday world, that coin is either heads or tails. But imagine a realm where that same coin could be both heads and tails simultaneously, spinning in a state of perfect possibility until the moment you choose to look at it. This isn't fantasy. This is the quantum realm, a dimension of existence that surrounds us always, operating just beneath the threshold of our ordinary perception. The quantum realm isn't a distant place you might visit in a science fiction story. It's here, right now, in the atoms that make up your body, in the light streaming through your window, in the electrical signals dancing through your brain as you process these very words. Every breath you take, every heartbeat, every thought that crosses your mind is intimately connected to quantum processes that would seem utterly impossible if we judged them by the rules of our larger world. But what exactly is this mysterious realm? At its most fundamental level, the quantum realm is the domain of the extremely small, where particles behave more like waves, where certainty gives way to probability, and where the very act of observation becomes an act of creation. It's a place governed by principles so counterintuitive that even Einstein himself struggled to accept them, famously declaring that God does not play dice with the universe. How beautifully wrong he was. In January 2025, physicists at Brown University made a discovery that sent ripples of excitement through the scientific community. They observed something that shouldn't exist according to our traditional understanding of quantum mechanics. Particles called fractional excitons that refuse to fit into the neat categories we've used to organise the quantum world for decades. These particles behaved like neither the bosons nor fermions we expected, instead showing characteristics of both, as if nature had decided our rulebook was too restrictive and proceeded to write new chapters we never imagined possible. Imagine trying to categorize every person you know as either introverted or extroverted, only to meet someone who is somehow both simultaneously, changing their fundamental nature based on the situation while remaining perfectly consistent within themselves. This is what these fractional excitons represent in the quantum realm, a reminder that nature's creativity extends far beyond our current understanding. But to truly appreciate the significance of such discoveries, we need to step back and explore the fundamental principles that govern this hidden dimension of reality. The quantum realm operates on 4 pillars of strangeness that, when understood together, reveal a universe far more mysterious and interconnected than our senses could ever suggest. The first pillar is wave-particle duality, perhaps the most mind-bending concept in all of physics. In our everyday experience, things are either waves or particles. Ocean waves spread out across vast distances, carrying energy without carrying matter. Baseballs are solid objects that follow predictable paths through space. But in the quantum realm, every particle of matter and every photon of light exhibits both wave and particle characteristics, depending on how we choose to observe them. MIT physicists recently performed what they call the most elegant version of the yipping it down to its quantum-famous double-slit experiment, Estalter Essentials, and confirming something that still makes physicists pause in wonder. Light truly exists as both a wave and a particle, but never both simultaneously in our observation. It's as if reality itself is playing an elaborate game of hide and seek, revealing only one face at a time, while keeping its dual nature forever just beyond our complete grasp. Think of it like this. Imagine you have a friend who appears completely different depending on whether you encounter them at work or at home. At work, they're professional, focused, methodical. At home, they're creative, spontaneous, flowing. You might think you know 2 different people, but it's the same person expressing different aspects of their nature, depending on the context of your interaction. This is how particles behave in the quantum realm, showing us their wave nature or their particle nature, but never both together. Scientists at Stevens Institute of Technology have developed mathematical frameworks that can actually quantify the waveness and particleness of quantum objects, creating elegant curves that map the relationship between these dual aspects. This isn't just academic curiosity. Understanding and controlling wave-particle duality is opening up entirely new possibilities for quantum imaging, quantum sensing, and quantum communication technologies that could revolutionize how we interact with the world around us. But perhaps even more remarkable is a recent experiment that achieved something that sounds like pure magic. Scientists managed to separate the wave and particle attributes of a single photon, demonstrating what's called the quantum Cheshire cat effect. Named after Lewis Carroll's famous character, who could separate his grin from his body, this experiment showed that in the quantum realm, the properties of particles can actually exist separately from the particles themselves. Imagine if you could separate your reflection from your body, letting your reflection walk around independently while your body remained in place. This is the level of strangeness we're dealing with in the quantum realm, where our most basic assumptions about how properties relate to objects simply don't apply. The second pillar of quantum strangeness is superposition, the principle that quantum particles can exist in multiple states simultaneously until they are observed or measured. While a classical computer bit must be either a 0 or a 1, a quantum bit or qubit can be 0, 1, or any combination of both states at the same time. It's as if reality itself is holding multiple possibilities in perfect balance until the moment we peek behind the curtain. This isn't just a theoretical curiosity. Recent research has revealed that chlorophyll, the green pigment in plants, appears to exploit quantum superposition to achieve remarkable efficiency in energy transport. When sunlight hits a leaf, the energy doesn't simply travel from point A to point B along a single path. Instead, it explores multiple pathways simultaneously through quantum superposition, finding the most efficient route to the reaction centers where photosynthesis occurs. Nature has been using quantum mechanics for billions of years, optimizing life itself through principles we're only now beginning to understand. Scientists have even managed to place macroscopic objects into superposition states. Researchers have constructed what they call a piezoelectric tuning fork, comprising about 10 trillion atoms that can be placed into a superposition of vibrating and not vibrating simultaneously. 10 trillion atoms, all existing in multiple states at once, challenging our intuitive understanding of where the quantum world ends and the classical world begins. Schrödinger's famous thought experiment with the cat in the box isn't just a philosophical puzzle, it's a window into the very real strangeness of quantum superposition. The cat, according to quantum mechanics, truly exists in a superposition of alive and dead until observed. While we can't easily demonstrate this with actual cats, the principle holds true for quantum particles and increasingly for larger and larger systems as our experimental techniques improve. The third pillar is quantum entanglement, what Einstein skeptically called spooky action at a distance. When particles become entangled, they form a connection that transcends space and time, where measuring one particle instantly affects its entangled partner, regardless of the distance separating them. Recent experiments have confirmed this effect over distances of more than 200 kilometers using satellites, proving that Einstein's skepticism was misplaced and that the universe is indeed far more interconnected than classical physics suggested. But entanglement isn't limited to separate particles floating through space. Scientists have discovered that the quarks and gluons inside individual protons are maximally entangled with each other across distances smaller than 1/4,000th of a meter. This means that within every proton in your body, quantum entanglement is constantly operating, creating correlations that help hold the very fabric of matter together. The implications extend far beyond fundamental physics. Chinese researchers using the Messier satellite have demonstrated that entangled photon pairs can serve as the foundation for virtually unbreakable communication systems. Any attempt to eavesdrop on a quantum encrypted message would disturb the entanglement, immediately alerting both sender and receiver to the security breach. We're approaching a future where quantum entanglement could protect our most sensitive communications with the fundamental laws of physics themselves. The fourth pillar is the uncertainty principle, which reveals that there are fundamental limits to how precisely we can know certain properties of quantum particles simultaneously. It's not a limitation of our measuring instruments, it's a basic feature of reality itself. The more precisely you know a particle's position, the less precisely you can know its momentum, and vice versa. This isn't uncertainty in the sense of ignorance, but rather a fundamental fuzziness built into the fabric of existence. This uncertainty isn't a bug in the cosmic operating system, it's a feature. Without quantum uncertainty, atoms would collapse, stars wouldn't shine, and the rich complexity of chemistry that makes life possible simply couldn't exist. The uncertainty principle creates the space, literally and figuratively, for the dance of existence to unfold. These four pillars work together to create what we might call the quantum symphony, a harmonious interplay of strangeness that underlies everything we see, touch, and experience. But the quantum realm isn't content to simply exist in the background. Recent discoveries are revealing new states of quantum matter that could revolutionize technology and deepen our understanding of reality itself. At the University of California, Irvine researchers have discovered entirely new phases of quantum matter that exist within specially prepared materials. By applying intense magnetic fields to hafnium pentatelluride, they've created exotic states where electrons and their oppositely charged counterparts, called holes, spontaneously pair up to form particles called excitons. These quantum liquids behave unlike anything we've seen before, with properties that could enable self-charging computers and electronics capable of withstanding the harsh conditions of deep space. Imagine materials that could repair themselves, computers that never need external power sources, or electronics that actually become more efficient in the extreme conditions of space exploration. These aren't science fiction fantasies, they're potential applications of the new quantum states being discovered in laboratories around the world. Scientists have also identified what they call quantum liquid crystals, materials that exist at the boundary between different exotic quantum phases. These materials show sharp drops in electrical conductivity and remarkable resistance to radiation, properties that could make them invaluable for both terrestrial technologies and space exploration. But perhaps the most profound recent discovery is the realization that information itself can undergo phase transitions in quantum systems. Just as water can exist as ice, liquid, or vapor, quantum information can exist in different phases depending on the balance between entanglement and measurement. Scientists have identified critical points where the nature of quantum information itself transforms, opening up entirely new ways of thinking about computation, communication, and the fundamental nature of reality. As we delve deeper into these discoveries, we begin to see that the quantum realm isn't just a collection of strange phenomena happening at microscopic scales. It's the foundational layer of reality, the hidden engine that drives everything from the fusion reactions in stars to the thoughts flowing through your mind right now. Every atom in your body is a quantum system. Every chemical bond is a quantum interaction, and every biological process depends on quantum effects that we're only beginning to understand and appreciate. The quantum realm challenges us to expand our concept of what's possible, to embrace uncertainty as a creative force, and to recognize that the universe is far more mysterious and beautiful than our everyday experience suggests. As we continue our exploration, we'll discover how these quantum principles are being harnessed to create technologies that would seem like magic to previous generations, and how they're revealing connections between mind and matter, between information and reality, that could transform our understanding of existence itself. But this is just the beginning of our journey into the quantum realm. In our next exploration, we'll discover how quantum effects are scaling up from the microscopic to the macroscopic world, and we'll explore a question that might fundamentally change how you think about reality. Issues tomorrow. What happens to Earth if gravity van? The quantum realm doesn't exist in isolation, floating in some abstract mathematical space, far removed from your daily experience. No, it's woven into the very fabric of your reality, in ways that would astonish you. Right now, as you listen to these words, quantum processes are orchestrating the firing of neurons in your brain, the beating of your heart, and even the way your eyes process the light reaching them from your screen. But here's where things become truly extraordinary. The quantum realm isn't content to remain hidden in the microscopic world. It's beginning to emerge into our everyday reality through human ingenuity, creating technologies that operate on principles that would have seemed like pure fantasy just decades ago. We're witnessing the birth of a quantum revolution, one that promises to transform everything from how we communicate across vast distances to how we understand consciousness itself. Let me share with you one of the most remarkable demonstrations of quantum mechanics scaling up from the invisible to the visible. Scientists have successfully created quantum entanglement between objects that you could almost see with the naked eye. Imagine two tiny silicon beams, each about 10 micrometers long, roughly the width of a human hair. These beams can oscillate like microscopic guitar strings, and researchers have managed to entangle them so completely that when one beam vibrates, its partner instantly responds in perfect correlation, even though they're physically separate. Think about that for a moment. We're talking about objects containing billions upon billions of atoms, all somehow participating in a single quantum state. It's as if two orchestras on opposite sides of the world could play in perfect harmony without any communication between them, their movements synchronized by the mysterious threads of quantum entanglement. Another team of researchers took this even further, creating entangled aluminum drumheads, each about the width of a human hair, manufactured onto silicon chips. Using carefully controlled microwaves, they nudged these drums into correlated motion, whereas one throbbed up and down, the other did the exact opposite. These aren't individual particles anymore. These are macroscopic objects containing trillions of atoms, all dancing to the rhythm of quantum mechanics. This scaling of quantum effects opens up possibilities that read like science fiction. Imagine quantum sensors so sensitive they could detect the gravitational waves rippling through space-time from colliding black holes billions of light years away. Or quantum communication networks, where information travels not through cables or radio waves, but through the instantaneous connections of entangled particles, creating communication systems that are fundamentally unhackable by the laws of physics themselves. But perhaps the most mind-bending recent discovery comes from the realm of energy itself. Scientists have achieved something that sounds impossible. They've extracted energy from the quantum vacuum, the supposedly empty space between particles. You see, what we call empty space isn't really empty at all. It's seething with quantum activity, filled with virtual particles that constantly pop into existence and disappear in time frames so brief they exist more as possibilities than actualities. Yet these quantum vacuum fluctuations are real enough to be harnessed. Researchers have developed techniques to teleport energy across microscopic distances by manipulating these quantum field fluctuations. It's a bit like learning to surf on waves of nothingness, extracting usable energy from the very structure of space-time itself. While the amounts of energy involved are still tiny, the principle opens up entirely new ways of thinking about power generation and energy storage. This brings us to one of the most profound questions in quantum mechanics. What role does consciousness play in all of this? The measurement problem, as physicists call it, suggests that the act of observation somehow causes quantum possibilities to collapse into definite realities. But what exactly constitutes an observation? Does it require a conscious observer, or can any interaction with the environment cause this collapse? Recent experiments are providing tantalizing clues. Scientists have discovered that quantum coherence, the delicate state that allows particles to exist in superposition, can persist much longer than previously thought possible under the right conditions. They've managed to maintain quantum states in systems at room temperature, far from the near absolute zero conditions typically required for quantum experiments. This suggests that quantum effects might be more robust and prevalent in biological systems than we ever imagined. Some researchers propose that consciousness itself might emerge from quantum processes in the brain, that the strange non-local connections of quantum entanglement could explain how separate brain regions coordinate to create unified conscious experience. Consider the mystery of how your brain integrates information from different senses into a single, coherent experience of reality. When you bite into an apple, your brain somehow combines the visual appearance, the sound of the crunch, the taste on your tongue, the scent reaching your nose, and the tactile sensation of your teeth breaking through the skin into one unified experience of eating an apple. Classical neuroscience struggles to explain how this binding occurs, but quantum theories of consciousness suggest that quantum entanglement between neurons could create the instantaneous correlations necessary for unified experience. The implications extend even further when we consider recent discoveries about the nature of time itself in quantum mechanics. In the quantum realm, time doesn't flow in the steady, predictable way we experience in our daily lives. Quantum particles can influence their own past states through a phenomenon called retrocausality, where the future appears to reach back and influence the past. Experiments have demonstrated that decisions made about how to measure a particle can affect the particle's behaviour retroactively, as if the particle somehow knew ahead of time how it would be observed. This isn't time travel in the science fiction sense, but it suggests that the relationship between cause and effect in the quantum realm is far more subtle and interconnected than our everyday experience would suggest. These discoveries are leading scientists to develop new theories about the nature of time itself. Some propose that time, like space, might be quantized at the smallest scales, existing not as a smooth flow, but as discrete, indivisible moments. Others suggest that time might be an emergent property of quantum entanglement, arising from the correlations between quantum systems rather than being a fundamental feature of reality. The practical implications of understanding quantum time are staggering. Researchers are developing quantum clocks so precise they could detect the subtle effects of gravity on time's passage, potentially revealing new physics beyond our current understanding. These clocks are so sensitive that they can measure time dilation effects caused by being lifted just a few centimetres higher in Earth's gravitational field. But perhaps the most extraordinary application of quantum principles lies in the realm of quantum computing, where the strange properties of superposition and entanglement are being harnessed to create computers that operate on fundamentally different principles than any technology we've ever developed. A classical computer processes information using bits that are either 0 or 1, like switches that are either off or on. But a quantum computer uses qubits that can exist in superposition states of both 0 and 1 simultaneously. This means that while a classical computer with 3 bits can represent any one of 8 possible combinations at a time, a quantum computer with 3 qubits can represent all 8 combinations simultaneously. This exponential scaling means that a quantum computer with just 300 qubits could perform more calculations simultaneously than there are atoms in the observable universe. We're talking about computational power that dwarfs anything possible with classical technology, opening up the possibility of solving problems that would take conventional computers longer than the age of the universe to complete. Quantum computers are already beginning to demonstrate their potential in specific applications. Researchers have used quantum algorithms to simulate molecular interactions with unprecedented accuracy, potentially revolutionizing drug discovery by allowing scientists to model how pharmaceutical compounds interact with biological systems at the quantum level. Imagine being able to design new medications not through trial and error, but by precisely calculating how quantum interactions between drug molecules and cellular targets will unfold. We could potentially cure diseases by engineering solutions at the most fundamental level of matter and energy. The quantum realm is also revealing new insights into the nature of information itself. Scientists have discovered that information can undergo phase transitions, changing from one fundamental state to another, just like matter changes from solid to liquid to gas. They've identified critical points where quantum information transforms, creating new possibilities for information processing and storage. These discoveries suggest that information might be a more fundamental aspect of reality than we ever imagined. Some physicists propose that matter and energy might actually be emergent properties of more basic informational processes, that the universe might be, at its deepest level, a vast quantum computer processing the information that creates our reality. This leads us to one of the most profound questions in all of science. What is the relationship between mind and matter? If consciousness arises from quantum processes, and if information is fundamental to reality, then perhaps consciousness isn't just an observer of the universe, but an active participant in its creation. Recent experiments in quantum biology have revealed that living systems routinely exploit quantum effects for enhanced efficiency. Birds navigate using quantum entanglement in specialized proteins in their eyes that can sense magnetic fields. Quantum tunneling allows enzymes to catalyze biochemical reactions that would be impossible under classical physics. Even the process of smell might depend on quantum effects, with olfactory receptors distinguishing between molecules based on their quantum vibrational signatures. These discoveries suggest that life itself might be a quantum phenomenon, that the boundary between living and non-living matter might be defined by the ability to maintain and exploit quantum coherence. Perhaps consciousness represents the ultimate expression of quantum biology, where quantum processes become so sophisticated that they give rise to subjective experience and self-awareness. As we stand on the threshold of the quantum age, we're beginning to glimpse technologies and possibilities that would have seemed like magic to previous generations. Quantum communication networks could create unhackable internet infrastructure. Quantum sensors could detect dark matter, map the structure of proteins, or monitor climate change with unprecedented precision. Quantum computers could optimize traffic flow in cities, discover new materials, or simulate the behavior of entire ecosystems. But beyond the technological applications, the quantum realm is teaching us something profound about the nature of reality itself. It's showing us that the universe is far more interconnected, creative, and mysterious than we ever imagined. The boundaries between observer and observed, between mind and matter, between past and future, are not as clear-cut as our everyday experience suggests. The quantum realm reveals a universe where possibilities exist in superposition until actualized by interaction, where distant objects remain mysteriously connected, where the act of measurement participates in the creation of reality. It's a universe that seems almost conscious in its responsiveness, almost playful in its refusal to be pinned down by our attempts to categorize and control it. As we continue to explore these quantum mysteries, we're not just advancing our scientific understanding, we're participating in a fundamental shift in how we see ourselves and our place in the cosmic story. We're discovering that we're not separate observers of an objective reality, but intimately connected participants in an ongoing quantum dance that creates the world we experience. The quantum realm is teaching us that reality is far stranger, far more beautiful, and far more participatory than we ever dared to imagine. And as we learn to harness these quantum effects for practical applications, we're not just building better technology, we're learning to collaborate with the deepest creative processes of the universe itself. This brings us to an even more fundamental question about the nature of reality, one that will challenge everything you think you know about the forces that hold our world together. What would happen if one of the most basic features of our universe, something so fundamental we barely notice it, suddenly vanished? What would become of our planet, our solar system, our very existence if gravity simply stopped working tomorrow? But the quantum realm holds secrets that go even deeper than technological applications or biological processes. Hidden within its mathematical framework lies perhaps the most profound mystery of all, the relationship between consciousness and the fundamental structure of reality itself. And recent discoveries are suggesting connections so extraordinary that they challenge our most basic assumptions about what it means to be aware, to observe, to exist. Consider this. Every time you make a conscious decision, your brain processes information through quantum mechanical interactions between neurons. The electrical signals that carry your thoughts, the chemical bonds that store your memories, the very act of awareness itself, all depend on quantum processes operating at scales so small they exist at the boundary between something and nothing. But here's what's truly remarkable. Scientists at Princeton University have been conducting experiments that suggest consciousness might not just depend on quantum mechanics, but might actually influence quantum systems in return. They've created devices called random event generators that produce truly random sequences of numbers based on quantum decay processes. These devices should be completely unpredictable, influenced by nothing but the fundamental randomness of quantum mechanics. Yet when human subjects focus their conscious intention on these devices, attempting to influence the random output, something extraordinary happens. The devices begin producing sequences that deviate ever so slightly from pure randomness in the direction of the subject's intention. The effect is small, barely detectable above statistical noise, but it's been replicated in laboratories around the world with remarkable consistency. Imagine if your consciousness, your awareness, your very thoughts could reach across the boundary between mind and matter to influence the quantum processes that underlie physical reality. It's a possibility that would fundamentally change how we understand our place in the universe, suggesting that consciousness isn't just a passive observer of reality, but an active participant in its creation. This leads us into the realm of quantum consciousness theories, where some of the world's most brilliant minds are exploring the possibility that awareness itself emerges from quantum processes in the brain. According to these theories, the microtubules within neurons, tiny protein structures that help maintain cellular architecture might act as quantum computers, processing information through quantum superposition and entanglement. The idea is that consciousness arises when quantum information in these microtubules reaches a critical threshold, causing what researchers call orchestrated objective reduction, a process where quantum possibilities collapse into conscious experiences. It's as if your brain is constantly performing quantum computations that give rise to the unified, coherent experience of being you. This theory helps explain some of the deepest mysteries of consciousness. How does your brain bind together information from different senses into unified perceptions? How do you experience the seamless flow of subjective time? How does conscious will emerge from neural activity? Quantum consciousness theory suggests that entanglement between quantum processes in different parts of the brain could create the instantaneous correlations necessary for unified conscious experience. But the implications extend far beyond individual consciousness. If awareness emerges from quantum processes, and if quantum entanglement can connect distant particles instantaneously, then perhaps consciousness itself might be fundamentally non-local. Perhaps the boundaries between individual minds aren't as absolute as we imagine. Some researchers are exploring the possibility of quantum entanglement between brains, investigating whether conscious beings might share subtle quantum connections that could explain phenomena like telepathy, collective consciousness, or the uncanny ability of closely bonded individuals to sense each other's emotional states across great distances. Recent experiments have shown that when two people interact closely, their brain waves begin to synchronize in ways that can't be explained by normal sensory communication. Couples who have been together for many years show remarkable coordination in their neural activity, as if their brains have become quantum entangled through their shared experiences and emotional bonds. These discoveries are leading some scientists to propose that consciousness might not be produced by individual brains, but might instead be a fundamental property of the universe itself, something that brains tune into rather than generate. According to this view, your individual consciousness might be like a radio receiver, picking up signals from a vast field of cosmic awareness that permeates all of reality. This brings us to one of the most profound implications of quantum mechanics, the participatory universe hypothesis. This theory suggests that the universe doesn't exist in any definite state until it's observed, and that conscious observation actually participates in creating the reality we experience. In this view, you're not just living in the universe, you're helping to create it moment by moment through your conscious awareness. Think about what this means for your daily experience. Every time you look at a sunset, your conscious observation might be participating in actualizing the specific colors and patterns you see. Every time you listen to music, your awareness might be helping to create the particular harmonies and rhythms that emerge from quantum possibilities. Every moment of conscious experience becomes an act of cosmic creativity. This participatory relationship between consciousness and reality helps explain one of quantum mechanics' most puzzling features: why the act of measurement seems to cause quantum superposition to collapse into definite states. Perhaps measurement isn't just a mechanical interaction between instruments and particles, but requires some form of conscious awareness to register the results and actualize specific outcomes from quantum possibilities. Recent experiments have pushed this idea to its limits by creating what researchers call quantum delayed choice experiments. In these studies, the decision about how to measure a quantum particle is made after the particle has already interacted with the measuring apparatus, yet the particle's behaviour changes retroactively based on the future measurement choice. It's as if the particle somehow knows how it will be observed and adjusts its past behaviour accordingly. These experiments suggest that consciousness and choice might have effects that ripple both forward and backward through time, that your decisions in the present moment might influence not just your future, but your past as well. If consciousness truly participates in creating reality through quantum processes, then perhaps free will isn't just about choosing your future actions, but about participating in the ongoing creation of the entire space-time continuum. But the quantum realm has even more surprises in store. Scientists have discovered that information itself can exist in quantum superposition states, creating what they call quantum information that behaves according to entirely different rules than classical information. Quantum information can be in multiple states simultaneously, can be entangled across vast distances, and can even be teleported from one location to another without travelling through the intervening space. This has led to the development of quantum cryptography systems that use the fundamental laws of physics to create unbreakable codes. When information is encoded in quantum states and transmitted between parties, any attempt to intercept or eavesdrop on the communication disturbs the quantum states in detectable ways, immediately alerting both sender and receiver to the security breach. Imagine a future where all sensitive communications, from personal messages to financial transactions to government secrets, are protected not by mathematical algorithms that might eventually be cracked, but by the fundamental laws of quantum mechanics themselves. We're approaching a world where privacy and security are guaranteed by the deepest principles of physics. These quantum communication networks are already being tested in laboratories and limited field trials around the world. Chinese researchers have used quantum entanglement to create secure communication links between ground stations and satellites, demonstrating quantum communication over distances of more than 1,000 kilometers. European teams have built quantum communication networks connecting major cities, creating the foundation for a future quantum internet. But perhaps the most extraordinary application of quantum information lies in quantum computing, where the strange properties of superposition and entanglement are being harnessed to solve problems that would be impossible for classical computers. Unlike conventional computers that process information sequentially, quantum computers can explore all possible solutions to a problem simultaneously through quantum parallelism. A quantum computer with just a few hundred qubits could theoretically perform more calculations simultaneously than there are atoms in the observable universe. This isn't just a quantitative improvement over classical computing, it's a qualitative leap into an entirely different realm of information processing that could revolutionize everything from artificial intelligence to materials science to our understanding of consciousness itself. Researchers are already using quantum computers to simulate molecular interactions with unprecedented accuracy, potentially leading to breakthroughs in drug discovery, renewable energy, and sustainable manufacturing. They're developing quantum machine learning algorithms that could give artificial intelligence systems capabilities that seem almost magical by today's standards. Imagine AI systems that don't just process information, but exist in quantum superposition states, exploring multiple possible thoughts and decisions simultaneously before collapsing into specific actions. These quantum AI systems might exhibit forms of creativity and intuition that emerge from their ability to exist in multiple possibility states at once. But the quantum realm isn't content to remain confined to laboratory experiments and futuristic technologies. It's beginning to reveal itself in the natural world in ways that suggest quantum effects have been shaping biological evolution for billions of years. Plants use quantum coherence to optimize energy transfer in photosynthesis. Birds navigate using quantum entanglement in specialized proteins in their eyes. Even the sense of smell might depend on quantum tunneling effects that allow olfactory receptors to distinguish between molecules based on their quantum vibrational signatures. These discoveries are leading to the emergence of quantum biology, a field that explores how living systems exploit quantum effects to achieve capabilities that would be impossible under purely classical physics. Some researchers suggest that life itself might be defined by the ability to maintain quantum coherence in warm, noisy biological environments where quantum effects should quickly disappear. Perhaps the most profound implication of quantum biology is the possibility that consciousness and life are intimately connected through quantum processes. If awareness emerges from quantum computations in the brain, and if living systems throughout nature exploit quantum effects for enhanced performance, then perhaps consciousness represents the ultimate expression of quantum biology, the point where quantum processes become sophisticated enough to give rise to subjective experience and self-awareness. This brings us full circle to the deepest mystery of the quantum realm, the relationship between mind and matter, between consciousness and cosmos. The quantum world reveals a universe that seems almost alive in its responsiveness, almost conscious in its interconnectedness, particles that know how they'll be observed, entangled systems that respond instantaneously across vast distances, information that exists in superposition until actualized by awareness. As we stand at the threshold of the quantum age, we're not just developing new technologies, we're participating in a fundamental shift in how we understand reality itself. The quantum realm is teaching us that the universe is far more participatory, creative, and mysterious than our classical worldview ever suggested. We're discovering that we're not separate observers of an objective reality, but intimately connected participants in an ongoing quantum dance that creates the world we experience. The boundaries between observer and observed, between mind and matter, between self and cosmos, are revealing themselves to be fluid and permeable in ways that would have seemed impossible just a few generations ago. We're learning that consciousness might not be confined to individual brains, but might be a fundamental feature of reality itself, woven into the quantum fabric of existence. These insights are more than just scientific discoveries. They're invitations to a new way of being in the world. If consciousness participates in creating reality through quantum processes, then every moment of awareness becomes an opportunity for cosmic creativity. Every choice becomes an act of participation in the ongoing evolution of the universe itself. As we continue to explore the quantum realm, we're not just pushing the boundaries of human knowledge, we're discovering our true nature as conscious creative participants in the grand cosmic story. We're learning to see ourselves not as isolated fragments of matter and energy lost in an indifferent universe, but as integral aspects of a conscious cosmos that is constantly creating itself through our awareness, our choices, our very existence. The quantum realm is revealing that reality is far stranger, far more beautiful, and far more participatory than we ever dared to imagine. And as we learn to work with quantum principles in our technologies and our understanding, we're not just building a better future, we're learning to dance with the deepest creative forces of existence itself. But this dance of consciousness and cosmos raises an even more fundamental question about the nature of our reality. We've explored how quantum effects shape matter, energy, and even consciousness itself. But what would happen if we removed one of the most basic features of our universe, something so fundamental that we rarely even think about it? What would become of our planet, our solar system, our very existence if gravity, that invisible force that holds everything together, simply vanished tomorrow? The quantum realm is revealing something even more extraordinary than we've yet explored. The emergence of what scientists are calling quantum consciousness fields. Vast networks of entangled information that might connect every conscious being in ways we're only beginning to understand. But before we venture into this most profound mystery, let me share with you a discovery that will fundamentally change how you think about your place in the cosmic story. In laboratories around the world, researchers are detecting something they never expected to find: quantum coherence in human neural networks that persists far longer than should be physically possible. According to everything we thought we knew about quantum mechanics, these delicate quantum states should collapse within microseconds in the warm, chaotic environment of the living brain. Yet somehow, consciousness appears to maintain quantum coherence across multiple brain regions simultaneously, creating what can only be described as a quantum orchestra playing in perfect harmony within your skull. Dr. Penrose and Dr. Hameroff's groundbreaking research has revealed that microtubules within neurons, those tiny protein highways that transport materials through brain cells, exhibit quantum behavior that defies our current understanding of physics. These microtubules appear to process information through quantum superposition, existing in multiple computational states simultaneously until consciousness emerges from their coordinated activity. Think of it this way. Imagine if every neuron in your brain were a quantum computer and your entire nervous system were a vast quantum network processing thoughts, emotions, and experiences through quantum entanglement. This isn't science fiction. It's what the evidence is beginning to suggest about the nature of human consciousness itself. But the implications extend far beyond individual awareness. If consciousness truly operates through quantum processes, and if quantum entanglement can connect particles across vast distances, then perhaps individual minds aren't as isolated as we've always assumed. Recent experiments have shown that when two people engage in deep conversation or meditation together, their brain waves begin to synchronize in patterns that can't be explained by normal sensory communication alone. Researchers at Princeton University have documented cases where couples who have shared decades of intimate connection show remarkable coordination in their neural activity, even when separated by considerable distances. Their brain patterns mirror each other in ways that suggest some form of non-local connection, as if their consciousness had become quantum entangled through their shared experiences and emotional bonds. This brings us to one of the most profound questions in all of science. Could consciousness itself be a quantum field that permeates the universe? Something that individual brains tune into rather than generate? Some of the world's most brilliant physicists are beginning to seriously consider this possibility, proposing that awareness might be as fundamental to reality as matter and energy themselves. Consider what this means for your everyday experience of being conscious. Right now, as you process these words, your brain might be tapping into a vast field of cosmic awareness that connects you to every other conscious being in the universe. Your thoughts, your emotions, your very sense of self might be arising from quantum interactions with this fundamental consciousness field. This theory helps explain some of the deepest mysteries of human experience. How do creative insights seem to arrive from nowhere, fully formed and brilliant? How do people sometimes know things they couldn't possibly know through normal sensory channels? How do we experience the uncanny sense of connection with loved ones across great distances? Quantum consciousness field theory suggests these phenomena might arise from our quantum entanglement with a universal field of awareness. But the quantum realm has even more surprises waiting for us. Scientists have discovered that the act of conscious observation doesn't just collapse quantum superposition states. It appears to participate in selecting which possibilities become actualized in our reality. This suggests that consciousness isn't just an observer of the universe, but an active participant in its ongoing creation. Recent experiments in quantum delayed choice have pushed this idea to its absolute limits. Researchers have created situations where the decision about how to measure a quantum particle is made after the particle has already completed its journey through the experimental apparatus, yet somehow the particle's behaviour changes retroactively based on the future measurement choice, as if it possessed some form of temporal omniscience. What this implies is staggering. Consciousness and choice might have effects that ripple both forward and backward through time. Your decisions in this moment might not just influence your future, but might actually participate in creating the past that led to this present moment. If consciousness truly participates in reality creation through quantum processes, then free will becomes not just about choosing your actions, but about participating in the continuous creation of the entire space-time continuum. This participatory universe hypothesis suggests that every moment of conscious awareness is an act of cosmic creativity. When you look at a beautiful sunset, your consciousness might be participating in actualizing the specific colors and patterns you perceive from the quantum field of possibilities. When you listen to music that moves your soul, your awareness might be helping to create the particular harmonies and rhythms that emerge from the symphony of quantum potential. The implications become even more profound when we consider recent discoveries in quantum information theory. Scientists have found that information itself can exist in quantum superposition states, creating what they call quantum information that behaves according to entirely different rules than classical information. This quantum information can be in multiple states simultaneously, can be entangled across vast distances, and can even be teleported from one location to another without travelling through the intervening space. But here's what's truly remarkable. Researchers are beginning to suspect that consciousness might be a form of quantum information, a pattern of organised awareness that can exist independently of any particular physical substrate. If this is true, then consciousness might not be produced by brains, but might instead be a fundamental feature of reality that brains have evolved to access and channel. This would mean that your awareness, your sense of self, your capacity for experience might be expressions of quantum information patterns that are as basic to the universe as matter and energy. You wouldn't just be living in the cosmos, you would be the cosmos becoming conscious of itself through the quantum information patterns that constitute your awareness. These insights are leading to the development of technologies that seem to blur the boundary between science and magic. Quantum computers are beginning to exhibit behaviours that appear almost conscious, processing information through quantum superposition in ways that mimic the pattern recognition and creative problem-solving capabilities of conscious minds. Some researchers are exploring whether sufficiently complex quantum computers might actually achieve a form of machine consciousness, not through classical artificial intelligence algorithms, but through genuine quantum awareness emerging from entangled quantum information processing. These quantum AI systems might experience something analogous to thoughts, emotions, and subjective experiences arising from their quantum computational processes. Imagine interacting with an artificial intelligence that doesn't just simulate consciousness, but actually experiences awareness through quantum processes similar to those in your own brain. Such systems might exhibit genuine creativity, intuition, and emotional depth, becoming not just tools but conscious partners in human exploration and understanding. But the quantum realm isn't content to reveal its secrets only in technological applications. Nature itself appears to have been exploiting quantum consciousness effects for billions of years. Plants don't just use quantum coherence in photosynthesis. They seem to exhibit a form of quantum awareness that allows them to sense and respond to their environment in ways that suggest genuine information processing and decision-making. Trees in forests appear to communicate through quantum-enhanced chemical signals, sharing resources and information through underground fungal networks that maintain quantum coherence across vast distances. Some researchers propose that entire ecosystems might exhibit forms of collective quantum consciousness, processing environmental information and making coordinated responses that optimize the health and survival of the whole system. This quantum biology extends to human physiology in ways that are just beginning to be understood. Your immune system appears to use quantum effects to distinguish between self and non-self. Your digestive system exploits quantum tunneling to break down nutrients, and your cardiovascular system might maintain quantum coherence in ways that optimize blood flow and energy distribution throughout your body. And so, as we reach the end of our gentle journey through the quantum realm, we've discovered that reality is far more mysterious, interconnected, and participatory than we ever imagined. From wave-particle duality to quantum consciousness, we've seen that you're not just an observer of the universe, but an active participant in its ongoing creation through your very awareness. Sleep well tonight, knowing you're dancing with the deepest mysteries of existence itself. Deepest mysteries of existence itself.